this is Ben Jacob again, coming from Olobo village in northern Uganda. This is part 2 of our series in the usage of drones for combating malaria here in northern Uganda. What we're going to do here is talk a little bit about the way we are going to distinguish these habitats using drones. We're also going to be talking about how we're going to be mobilizing young men in order to cover these habitats, in order to lower the endemicity and the transmission of malaria in this village. So I would like to now begin to talk with the leader of this village himself and talk a little bit about how many people are living here. So I would like to introduce at this moment the LC1. His name is James. Hi James. I would like to begin by asking you, how many people live in this village? 1,022. Do you know how many children there are here?
I know.
How many are there?
500.
500, wow. Do you suffer a lot of malaria here?
It's too much.
In terms of the development of your agricultural village, malaria affects your village then?
Yes.
How so? Can you explain?
Because it
as James is talking to us about the problems of malaria in this village, it's not just only about the sickness, but malaria can affect the economy of this village. So what we're trying to do is trying to lower the endemicity by using a natural methodology along with drone technology to destroy the transmission of malaria in this village. So now we're going to move into the village and show some of our techniques. Thank you. So here we are with Denise Olobo. He's a vector control officer here in Gulu district. He's going to tell us a little bit about controlling breeding sites here in Olobo village.
In Olobo village and the rest of other places in Gulu district, much of the breeding normally comes because of the heavy rains that starts from around April to November every year. And during this time, there is always a lot of breedings that take place in these breeding sites that are around the road. They are normally tire marks, there are roadside pools, there are other places which are hoof prints. So in these breeding sites, the mosquitoes, hundreds and hundreds of anopheles emerge from these sites, go to the places where human beings stay, bite them, and then transmit malaria. There has been also the use of long-lasting insecticide-treated nets in the region, but this has not actually had its impact because most of the mosquitoes are also changing their behaviors. They prefer to bite people from outdoors. They bite them before even they go to their bed. So it is making the long-lasting insecticide-treated net not to have its impact. So if we can destroy these breeding sites, we are going to have a very big impact in controlling malaria vectors.
So I'm here now with Tom Lakwo from, as you recall, from the series part 1. Tom's going to talk to us a little bit about usage of drone surveys in the past here. Go ahead, Tom, please.
Thank you, Ben. Our colleague told us about the breeding sites in Olobo village, Gulu district. His description is about types of breeding sites found in this area. Success in any livestock source management, or particularly destruction of breeding habitats from Anopheles mosquito, depends on proper mapping of where it is. As you can see, some of these sites here may be difficult to find within the environment of the village. For ground team to map maybe a Olobo village, it can take them about 4 to 6 weeks. This one is quite a lot of time. For timely intervention, we need a method that can identify even small breeding sites, hoof prints, tire marks, etc. So the introduction of the drone technology has assisted in trying to map this breeding site within a very short time. This at the same time also translates into timely intervention in controlling malaria in this region.
This is drone. As you can see, we have the remote controller here. I'll fly it up as it moves to the places where we can coordinate and identify where mosquito breeds.
This is the most vital part of that what we're doing here in this village. We're going to show that we can use drone technology to find all these habitats in a very minute time. You heard Tom Lakwo tell us that it takes 4 to 6 weeks. We believe we can do this in less than 2 to 3 days. So this is the most critical part of our mapping. So I'm going to now let Moo take it away. So as you can see that this is a very, very quick methodology. If we were to mobilize teams to be able to do something like this, it would take an extensive period of time. One of the advantages we have with an aerial remote sensing product such as a drone is that we can get immediate real-time mapping capability. So one of the most important factors of what we're doing here is being able to map malaria breeding sites in real time. I will download that into a handheld device, which then will be given to ground control teams to then mobilize teams to where these habitats are in order to use some sort of larval control strategy.
Now here we are just trying to identify through using the global positioning system to identify those places that we moved, and drone will help us to quick find the places where these mosquitoes breed. So here is a sign of, we mark the points, and this is the first point that we are trying to see whether we can make a circular or a grid mission to identify the places.
Hi, this is Ben. Here I'm going to do a little bit of teaching of how we were able to take the drone imagery and then find other unknown habitats within our study site village. So the first thing that we did was we were able to sample some capture points of anopheline habitats in our intervention village. In so doing, we were able to also take the GPS capture point coordinates. In so doing, we were able to fly the drone over these particular localities. That data was then exported into a convoluted neural network. The convoluted neural network was able to now then find other unknown habitats using the video data. By so doing, we were able to mobilize village teams in order to use soil substrate to eliminate these habitats. The idea being that we're able to now find these habitats in real time and then use trained village personnel to find these habitats and then neutralize them using soil substrate. One of the first things we were able to do within the system was to find the habitats of all different types. Because anopheline habitats breed in multiple different type of habitats, we had to be very careful not to use one particular type of capture point. We used different type of habitats. For example, this was a streamside ditch. We had agro ponds, and we also had grassy habitats. Now, by taking the coordinates of these capture points, the neural network system was able to identify other ones of similar structure within the village. Now, our village was a 5 kilometer by 5 kilometer approximate measurements. Now, while we were flying the drone over the other habitats, the handheld devices were giving us GPS locations of these unknown habitats. Furthermore, we were able to get a signature of an anopheline gambia using the video analog data. This also was used in the training model to find and prioritize other habitats in the village. Now, in so doing, we were able to classify our habitats as hyperproductive, aquatic, or dry. By so doing, we're also able to now send our teams to eliminate these habitats based on the signature that we got from the anopheline gambia.
So I want to inquire from you, how many places or how many habitats have we missed in the coordinates that we got?
We got everything, we have not missed any.
What we're going to do right now, we're going to spray inside this house. We have put our ground sheets on the floor to collect all the mosquitoes that will fall after the spray. It's a knockdown insecticide actually. One person will spray from inside, another person sprays from outside, and we give it like 15 minutes, and there will be a lot of mosquitoes that will be knocked down on these ground sheets that have been spread on the floor. And we want to use this method to determine the population density of indoor resting adult Anopheles mosquitoes.
Okay, let's go forth. So one of the reasons we're doing that, what we're doing here, called Seek and Destroy, is to try to prevent malaria so these children have a fine tomorrow. I'd like to say goodbye from Akonibino village.
We love you. Thank you very much.
Bye.